So good morning, everyone, or afternoon, as the case may be. My name is Mark Mays. I'm an applications engineer with OutBack Power. And welcome to the webinar today on the FLEXmax 100 and some of the advantages we have over previous models and some of our competition. And I just wanted to mention a couple of ground rules, not much, other than please save your questions for the end, or you can ask them now. They'll be collected throughout the presentation, and then at the end of the presentation, I can go ahead and address those questions. The webinar will last about 45 minutes. And I wanted to also mention Glenda Lee Espy, my fellow applications engineer and colleague, we'll be repeating this webinar on Friday, 2 days from now, at 11 o'clock. And so if for some reason you need to duck out or want to tell some of your colleagues about it, this will repeat in 2 days. So without further ado, we'll go ahead and get started. So we are introducing the FLEXmax 100 charge controller. And we are having come up with an agenda here. So the topics to cover are the FM100, kind of an overview of the product. We're going to talk about string sizing and some of the other advantages that the FM100 has to offer. And we're going to discuss rapid shutdown and other NEC compliance. And we're going to kind of compare how we do this with the FM100 versus some of our other products, and how the variation in solutions are, and how we think we're doing a good job of addressing that NEC compliance. And then we'll wrap up with some questions. So the our FLEXmax product line includes the FM60, which is our value product, 60 amp charge controller, the FM80, which has been around, and we've sold tons of these worldwide, and now the FM100, our 300 volt charge controller. It's our premium product with increased harvest and performance, and we believe is also going to reduce system cost and installation, which is going to be a big benefit to all you installers out there. So when you're looking at the lineup here, the FM60 is a 60 amp charge controller at 150 volts, has an internal cooling fan. It's fully mate compatible with all the different flavors of mate that we've come up with. The FM80, our 80 amp charge controller with 150 volt DC maximum on the input, has a top mounted cooling fan for easier access and increased cooling performance. It's also fully mate compatible. Now we have the FM100, our 100 amp charge controller with the improved MPPT algorithm. It's rated for 300 volts DC on the input. It does employ active cooling. It is compatible only with the Mate 3S. That's our new Mate 3 that we've started shipping, I believe, a couple months ago. The old Mate 3 is no longer in production. And it's also our access port compatible if you wanted to access it via Modbus control or via our Optics RE remote monitoring control software. It is outdoor rated. That is essentially the same enclosure as our FM Extreme, which has been discontinued. And this does employ built-in ground fault protection, and the firmware is field upgradable. So that's kind of just a basic rundown. Some other features, again, we believe that by reducing the overall system component count, complexity, it's going to reduce installation time and provide for an overall more cost-effective solution. We engineered, like all of our products, for reliability. We did extensive quality and reliability testing, including the halt testing. It is in the NEMA 3R enclosure with an IP54 ingress rating, so this is definitely something you can hang outside, and does include a 5-year warranty. So we really feel like we've come out with yet another solid, reliable product from OutBack. We do meet the NEC 2014 and 2017 compliances, including a rapid shutdown functionality inside. Arc fault is included with the ICS Plus. Internal arc fault, our ICS Plus is our combiner box solution, which I'll be talking about more. And the arc fault internal to the FM100 is on our product roadmap and will be incorporated at some point in the future. Right now, it does have internal ground fault protection, which is new, so you no longer need the ground fault detection interruption or GFDI breaker. It's no longer required, and we believe our new MPT algorithm from the testing we've done is going to more quickly achieve a cell state when you're grid connected and charge the batteries faster when you're off grid. So some of the key specs, the nominal voltages, it supports a 24, 36, and 48 volts, maximum 64 amps on the input, 100 on the output. The maximum open circuit voltage is 300, or technically it's 298 because it is rated at 250 volts plus battery voltage. And unlike some of our competitors, that is an operating range, not just a tolerate range. So it will fully operational from 250 plus the battery voltage. So the average and peak power conversion is gone up a little bit. So the in the 48 volt system, we're at 97%, and a peak conversion we've measured as high as 98.8, or essentially 99%. So very efficient system. We have rapid shutdown on the accessory terminals, the aux relay with some added functionality from our previous FLEXmax line, battery sense leads, which is really a huge benefit, and I'll talk more about that later. And then the environmental we've talked about already, ground fault, operating temperature, minus 25 to 60 C. In terms of system interface, there are some LED indicators that indicate what mode it's in, where it's absorbed or float, or whether it's in silent or not. Then for remote operation, it's the Mate 3S only, or through the access port. Dimensions. Again, it's a little bit bigger than the FM 80 and 60 FLEXmax series, and as mentioned before, the 5-year warranty. So we have an updated board layout and mechanical design that allows for more power to be produced. When we came out with the FM Extreme, we had the heatsink on the back, and that's been gone through and redesigned. And so we have this expanded input operating voltage from 20 volts to 298. We round up to 300 in our promotional material. It does employ active cooling, and again, we talked about the peak efficiencies and our improved MPPT algorithm. So we have this 300 volt VOC, which enables a 2-string array, which will reduce the balance of system and installation costs. We have the 100 amp output current, allows for higher power modules and arrays. And so some have the amperage, some have the voltage, but only OutBack has the 5 kW power available at all of our operating voltage and current. So this is kind of a unique position. We'll be talking about that shortly. But first, some people have asked, why doesn't OutBack do a 600 volt charge controller? We've gotten this feedback. And what's interesting is if you look at the power limit of 80 amps on a 600 volt controller. So if you're connected to a 48 volt battery bank, which most systems are these days, that's going to give you, if you do the math, 3,840 watts. Okay, so now if we come over to the input side, so let's say that we could, connect enough modules in series, like in this case, 320 watt module, have 14 in series, gives us a 574 volt VOC. And if we divide that into our power constraint, because this is how much power, the maximum at 80 amps that we can convert is 3,840. And even if we put this up at, say, 52 volts, say your cell voltage is 52 volts, that'll give you a little over 4,000. But even so, you divide that by 574, you're at 6.7 amps IMP, and in a 320 watt module, that's more like about 10 amps. So you're not even up to the maximum IMP. So you're really not even making full use of what's out here. And you'll see that we actually can get more power out of a 300 volt charge controller than we are in this example. So by having two strings of 7, we can actually get up more like about 4,400 to 4,500 watts. So really, a single string versus two strings, it offers no power advantage. There's no real BOS or installation cost advantage, because on a two-string array configuration, you can use a Y connector and not require any fuses. So essentially, 600 volt charge controllers are larger, they're more expensive, and even in this example, you can see they will actually produce less power, not more. And so this is why we decided to go with the 300 volt charge controller. And there's even been, we've seen quotes up on the wrenches where people have said, effectively these 600 volt charge controllers are basically they're a 300 volt charge controller. Is how they're being used. So that hopefully will answer that question. Okay, so the wiring compartment, this is kind of where all the user accessible ports and terminal blocks and everything is located. This one port over here, what we call the hub port, so that would plug into into our communications hub, or if you're just a single charge control application, you could plug the Mate3 or S or the access port directly there. This port and this port are for future expansion. The remote temperature sensor goes into this port. The SD memory card, it's a micro SD card, goes into this port, and this is how you would do the firmware upgrade is with that card. So even if you're using the Mate3S to do the upgrade, you still have to have that firmware loaded on this SD card. And then the rest of these things going on down here I'm going to talk about shortly. Oh, I just wanted to mention here on the bottom this ground fault fuse. I don't know how well this shows up in real life. This is black, this little block behind the jumper. It's a fuse, so when you pull that up, the fuse is inside of it. And so it's basically, like a fuse holder that you can also use for changing the fuse or pulling it in applications where that's required. Okay, the DC to DC ground jumper. This is the DC minus side, the battery side, and then this is the ground. So this is what provides our DC minus to ground bond. In our GFDI breaker, there's the green and white wire that goes to the half amp fuse. On a FM 60 or 80 system, that GFDI provides that bond between the DC minus and the ground. So you'd leave this jumper in place for a single FM 100 install, and also even if you add more FM 100s in parallel, then you would remove the jumpers in all those ones, like in the 2 or more, but you would still leave this in place. So one of these jumpers has to be in place, the others have to be removed. Also, only one ground fuse is in place. So the main or first one, you would leave the fuse and the jumper in place. Everything else, all the other FM100s, you would pull the ground jumper and the fuse. Also, you would remove the jumper if you wanted to float the array for some reason and disable the internal ground fault function. This is something you would normally do, possible in a positive ground situation you might. And if you are in a positive ground, you would definitely pull this jumper, and then you'd use an external DC plus to ground bond. So if you're in a positive grounded system, you would remove that jumper anyway. And as mentioned earlier, remove the ground fault fuses for multiple FM100s except for one. So looking at the auxiliary terminal block, we have a rapid shutdown function inside. Now you still need, like in our case, we have what we call a rapid shutdown initiator. So this switch would close, and that would go to this pins 1 and 3 that you can see over here. So it'll go 1 and 3. And if the rapid shutdown is not being used, then there would be you would need to employ a jumper between pins 1 and 3 over here. So in this case, with a single charge controller, you would have, ignore this charge controller B for a moment. So these two lines would come off the rapid shutdown initiator. They go to 1 and 3. If you were to employ a second or more charge controller, then you would take 2 and jumper it over to 1, and 4 and jumper it over to 3, and then the next one you do the same. So this number 2 would go to 1 in the next one. This number 4 would go to number 3 in the next, and so on. So you would daisy chain them all along a line. And what that does is they all have to achieve a rapid shutdown condition in order to continue the daisy chain on. So if even one of those in the daisy chain does not achieve rapid shutdown, you don't get a confirmation. And I'll talk more about that coming up, by the way. Okay, so another, we have an aux port like we have in our other charge controllers. It's a 12-volt relay at 250 milliamps. The relay on-off function can be reversed for increased functionality, which is really kind of nice. That let's say that you have a night light, you're using the night light function, so when the PV array goes dark, if you will, rather than when the charge controller hits a sleep state, rather than turning on the relay, you can set it up so it would turn the relay off. So you have that reverse functionality, if you will. We call it polarity, but it's not really making it go negative 12 volts, but it's the function is being reversed. So there's a lot of different functions, vent fan and PV trigger, air output, night light, diversion. A lot of these you probably, if you're familiar with the other FLEXmax products, are familiar with those functions. But we did add something called rapid shutdown. So in place of, and this will become more clear later on when we talk about our rapid shutdown system, but instead of using this remote trip breaker and some other things we have to do with the FM60 and 80, what we do is when we get a rapid shutdown, there's an auxiliary terminal here, and that goes into the rapid shutdown pins on the charge controller. When we achieve rapid shutdown, this aux port will turn on, and then we need to have that go to relays such as our OBR16 relay. It's a 12-volt activated relay. And then the contacts, we can use the normally open or normally closed contacts here to go to this J4 connector to confirm that rapid shutdown has been achieved. So that's the confirmation. So this would, command it to go into a rapid shutdown, which basically means the output turns off and the input goes down to less than 30 volts. Well, I think in 2014 it was less than 30 volts in 30 seconds, and now I think it's less than 80 volts in 10 seconds, or pardon me if I'm a little fuzzy on that. But so anyway, the bottom line is that the input goes down to a safe condition within the specified amount of time. On the older FLEXmax 60 and 80, the capacitors were not discharged low enough, fast enough, so we used something called the remote trip breaker that would, open up that PV input. And again, I'll be talking more about this, and we'll show you on some diagrams that might make more sense. But this is the equivalent of our remote trip breaker and breaker control power supply solution. So it's a little bit simpler solution. Okay, and then one feature I was really happy to see was the battery sense leads. This is something that's been done in a lot of industries for a lot of different pieces of equipment, especially heavy current carrying equipment. I've been on a number of field installations where certain arrays were in a sleep state, or what we call X-absorb or external absorb state, where essentially the array was not producing. And what can happen is that when you have multiple charge controllers in operation, and you either get these main power conductors with different lengths, or even on one charge controller, maybe it's only conducting 10, 15 amps, and another one is conducting 60, 70, 80 amps, they're going to get different voltage drops just because the different current going through their conductors. And what happens is at the DC terminals inside the charge controller, which is where the voltage is measured on the charge controller internally, it says, oh, this other charge controller or something out there is putting out a higher absorbed voltage. I can't meet that voltage. I'm only allowed to go up to what I'm reading, 57.6 or whatever it is. So I'm just going to go offline because something else is higher, or sometimes they just go into a silent mode. And so to alleviate that, we now have, and you can overcome that by calibrating your charge controllers, and that process being you put a voltmeter on the battery bank, and you calibrate that voltmeter that's placed on the battery bank, not at the terminals. But anyway, now what we have is we have the battery sense leads, which we put on pins 7 and 8, and there's no high current going with this. It's just basically a voltmeter. So we got our voltmeter out here on the battery bank, and we can daisy chain this, so we only need one connection to the battery bank, and then we can daisy chain that reading over to the other charge controllers, and they're all going to read the same because there's no real current coming through these lines here. There's not going to be any voltage drop per se, and that's going to give us a much more accurate reading. We don't have to worry about calibrating the charge controller to the battery bank. We don't have to worry about charge controllers dropping offline when one goes higher than another. So this is a really, really nice feature that one of those subtle things, but is really going to help the arrays produce more often. Okay, so now let's take a look at some different charge controllers and see kind of what the advantage really is with the 300 volt and 100 amps charge control. So looking at the FM80 with a 40.8 volt VOC, we would do a typical 3 modules in series, which is pretty much everything from 200 some odd watts up to 300. You're pretty much going to be doing 3 modules in series. That means you have to have 4 strings and all the associated BOS with that, and that gives you 3,840 watts. Now let's come over to one type of charge controller that's out there, 100 amps at 240 volts. And let's see what we have here. So we're still going to, because of the 240 volt limitation, we're going to be limited to 5 modules in series. And to achieve something close to the maximum power, we're going to have 3 strings of 5. Okay, that gives us 4,800 watts. Now let's go over to the next example, 55 amps at 250 volts. And this particular example is spec'd at 250 volts plus battery voltage. Well, we say 250 volts plus battery voltage, but that's operating. This it's a safety zone. So if you go between 250 and 298, it's not going to produce anything, but it's not going to hurt anything either. So it's just like a safety zone. It's not really producing above 250 volts, and it's limited to 55 amps. So this case, yeah, you can put more in series, but you really haven't achieved that much. In fact, you're even less power than the FM80. But you do have the advantages of 2 strings, I guess. But now we go over to the FM100. It's true operational to well, it's up to the operation, I think, at 290. It actually goes into standby mode, and it is rated to 298. So it could go above, creep up above to 298, but it actually operates to 290. And so that gives us 4,480 watts. So we've got a 14 module array versus a 15 module array. So we're giving up 1 module, but we have the advantage of a 2-string array, which allows us to reduce the need for fuses and all the other BOS. It just gives us a much easier with 2 strings than if we were to have 3 or 2 at reduced power. Okay, so now we're going to talk about some of the NEC compliance issues, some of the parts of the NEC 690 code. We have the first fully compliant rapid shutdown system. This is specified as a PVRSS. There is another competitive solution out there called a PVRSE. And the difference is that the PVRSS is a UL listed solution, whereas the other one, I believe, is like a design to meet or something like that. And so in this particular case, the AHJ, it's my understanding, if it's a PVRSE, assumes the liability and responsibility for everything being done correctly versus the PVRSS, which is a fully UL listed and compliant solution. So this addresses the 690.11 arc fault protection. So there is arc fault protection inside of here. So this covers all the bases on our FLEXmax series with regards to arc fault. I'll talk a little bit more about arc fault. I'm not sure if I do or not, so I'll just mention it right now. The arc fault protection, we did extensive testing on it, both in our applications engineering tech lab as well as our engineering lab. And one of the more common complaints that we had was that there was a lot of nuisance tripping with arc fault, or in the case of one manufacturer, arc fault and the ground fault detection did not play well together. So we wanted to avoid these problems. So we did extensive testing. We got some, common household loads that are known to be noisy, like electronic ballasts, compact fluorescent lights, light dimmers. In fact, I put a compact fluorescent light in the light dimmer, and just trying to create the worst case scenario that we could with regards to both induced and radiated noise. We put those loads physically close to the radiant load center, so we could get both radiated and induced noise, trying to get this thing to trip, and we really couldn't get it to false trip. So we really, and we went through different revisions of software with our component supplier to make sure that we had this. So we really did a lot to really make sure that our arc fault protection was not going to false trip. And for me, I was beginning to wonder if it was really going to trip at all. So I put a circuit breaker, one of our DIN mount breakers, in series with it, and I loosened up the screw terminal on it and kind of moved the wire around inside. And I saw some little sparks, and it wasn't doing anything. And finally, I saw a bigger spark, and that did make it trip. So yeah, it does trip. It really should not nuisance trip for you. Okay, so we also have a rapid shutdown solution, and then the disconnecting means that locally that would be on the combiner box, in terms of the switch that you see on the side here, and as well as this is the remote trip breaker to disconnect our PV input, because we can backfeed a higher voltage onto that line. Again, talk more about all this in the coming slides. So that is our total compliance solution. Okay, so if we look at this illustration, so we have the UL 1699B is what protects on the arc fault. So our arc fault detection is inside of here. The rapid shutdown, we have a contactor that opens these conductors up. We have our UL 1741 with the PV rapid shutdown. And then we have this remote trip breaker, which if we're using the FLEXmax 1680 charge controllers, will open up their input. So these breakers would go in the place of a normal like 80 amp PV breaker that people use on the inputs. You'd use the remote trip breaker instead of that. And then you have to have a breaker control that can sense, that can make it trip, and then sense that it did trip, and all of that. And as I discussed earlier, we can do that just using the auxiliary terminals in our RBR16 relay, which we discussed earlier. So this is essentially how this all fits in. Okay, so inside the combiner box, if you are using more than 2 strings, then they would come in on these fuses, and then the other side of the fuse would go through the arc fault detector. There's actually 2 holes in this thing, one down below and one above. And then those strings would get combined on this side of the contactor. This is a really heavy duty, very high quality and a little bit spendy contactor, but it's really stout and reliable DC contactor. And so this is activated under 3 different conditions. One, the local disconnect. We'll send a signal to the control board saying, hey, open up the contactor. If there's an arc fault, that will also signify to the control board to open up the contactor. Also, rapid shutdown. If we receive a rapid shutdown on these pins here, on these connectors from the RSI, the rapid shutdown initiator, then that would also cause this DC contactor to open. So this is this contactor, again, locally, arc fault, or rapid shutdown. Another nice thing about this is this arc fault detector can be reset remotely just by using the RSI. So, if you, the scenario being if the first responders come and the firefighters come and pull the meter, initiate a rapid shutdown, that's going to reset the arc fault. Well, you can also just, there's a little arc fault light here. If we initiate a rapid shutdown, that will turn power off to this, which will reset the arc fault detector up there, so we don't have to climb up on the roof just to do an arc fault. Clear. Okay, so the rapid shutdown, this light comes on when the array is in its normal condition of solar on. When we initiate a rapid shutdown, then this, when everything's been confirmed to be shut down, when we get a confirmation from either the charge controllers and the combiner boxes, then this light comes on. Then we also have the arc fault circuit interrupter indicator here that's saying, hey, one of those combiner boxes, you can daisy chain up to 6 combiner boxes with this RSI device. So it just says, hey, one of those combiner boxes is had an arc fault. You can go ahead and initiate a rapid shutdown, turn it back on, and hopefully that'll clear it out if it's just a nuisance trip. If not, then you would need to climb up on the roof and see which, there's also an arc fault indicator on each combiner box. So any one or more of the combiner boxes that had this light on, you know that experienced an arc fault trip. Okay, so we have some auxiliary functions inside of the RSI. So there's increased functionality. So you can get the RSI status command out, which again, as I mentioned earlier, this would be going to the combiner box saying, hey, that there's been we need to initiate a rapid shutdown. RSI safe status in, saying, again, that could come off of like the FM100 aux port, that, hey, there's this RSI safe status has been met. And then also, because we do sense an arc fault up off the combiner box, you could have an alarm, say, inside the house, either an audible or visual alarm, so the site owner can know if an arc fault has taken the array offline, because otherwise they might have experienced an arc fault trip and not known it, and they're just sitting there and wondering why their PV system is not producing. Another kind of interesting input here is the RSI external in. So you could even do a trip from either a switch inside the house, or you could connect this up to one of the other aux port relays, like one of our dry contact relays, which we have on the Radian, or the FNDC battery monitor also has a dry contact. And you could use our remote monitoring control software, the Optics RE. You could be, from your home office, you could detect that there's been an arc fault, and you could reset the system by doing a momentary rapid shutdown, which would reset the system and possibly clear it. And you could just, toggle that FNDC or Radian relay contact remotely. A couple different layout options with the ICS Plus. One is you could have the control wires and the power conductors in a single conduit come into whatever load center, whether it's a Radian load center or one of our flex power load centers. And then that would go to and from the RSI. A little bit different scenario with the FM100. We just need to provide power to this instead of control lines. I'll talk about that later. But just if you're going to mix the control wiring with the power conductors, make sure it has the same rating, like you're using 600 volt conductors on your power conductors, and then you also want to have 600 volt rated insulation on your control wires. Oh, another nice thing too, I showed it. Yeah, if you notice that there's a color code, black, red, black, white, and green. This is a common, if you buy standard off-the-shelf 4-conductor control wire, like some 18 or 16 gauge control wires, it will have the same color code. So it makes it easier when you go to install the system you can use, your installers can just say, okay, red to red, black to black, white to white, and so on. So it makes the missed wires much more difficult. Another possible layout would be if you had a separate conduit for your power conductors into the load center, and then just use surface mount control conductors. So you can get some sheathed 4-conductor control wire and just staple it right to the siding or whatever works. It's just important to note that this RSI is rated for 24 volt, 24 volt, 30 volt max enclosure. So we can't pass the power conductors through the RSI. Another way that we can use this auxiliary port on the rapid shutdown initiator is there's some cases when let's say that there is a fire, the firemen, they pull the meter, initiate a rapid shutdown, okay, and so that rapid shutdown that makes the lines from here, from the output of the combiner box to the input here, so it makes these wires safe, okay. All the AC lines inside the house are dead, except when we remove the input power to the inverter, then we go into battery backup mode, and all the backup load panel loads are now hot. So there's our interpretation, or the way we've seen this, is it's not really required to make these devices hot. That's mostly for concerns about being able to safely make holes in the roof. But some HJs, we're told, do want to make sure that when there's a rapid shutdown, that the backup loads are also disabled. So we have a way to do that with our inverter, which I believe is unique. So if we use this J3 connector off the RSI and we initiate a rapid shutdown, we can also send these wires to our inverter on-off pins. All of our inverters have this. You have to just pull the jumper. So when we pull the jumper, now effectively, this, contact here being open or closed will control whether the inverter is on or off. And so now when a rapid shutdown is initiated, that will go to the inverter on-off, turn the inverter off, so it has no way to power loads from the batteries. So again, this is something I would think that if you're running control wires, it's not that hard to implement. I would think you would want to implement that anyway, but that's up to you and the site owner and the local AHJ. So the comparing the rapid shutdown between the FMs and versus the FM100. So here we have our 4-string array coming in to 4 fuses. Those go through the arc fault detector, get combined on the input side of the contactor, and then that goes on out to the remote trip breaker, because this is the line that the code says has to be dead. I think with the 2017 or 2019, whichever it is, 2020, whatever's the latest one is, I think this has to be located within a foot of the array now. So anyway, so we have to have this remote trip breaker. There needs to be some control wiring between these two devices. The power supply, this is a 24 volt power supply, so it converts the 48 volts or 24 volts to a 24 volt power. Along with these control lines goes to the RSI and then on up to the combiner box. And then also, in addition to that, there needs to be a ground fault detection interrupter, a GFDI breaker on the output side of the charge controller. Now, if we compare that to the FM100, we can bring in the two strings into a Y connector. We do need to still run it through our arc fault because we don't have arc fault internally to the FM100 yet. Through the combiner, plus we need to have this contactor regardless. Even if we didn't have the arc fault, we'd still need we need to have this contactor anyway because we have to have a way of disconnecting power between the array and the input side here. But now we don't need a remote trip breaker. We can just use a standard 80 amp breaker on the input side, on the PV side to the charge controller. Also, we don't need the special GFDI on the output, so we can just use like a 100 amp or 125 amp circuit breaker here. We still need to provide power, so we have there are some low cost power solutions out there, like $30, $35 for take our 40 volt in and provide 24 volts on the output. So we just need to provide two power like a 18 gauge or 16 gauge twisted pair up to the RSI, and and then we have inside, as I mentioned, we have the rapid shutdown function inside, and that's what takes the place of this breaker control, which is like about a $250 device here, and the remote trip breaker. So bottom line is there's no fuses if you're using a two-string array, no remote trip breaker, no GFDI, no breaker control power supply, and so that's going to reduce some cost. We do have a simpler low-cost combiner on the roadmap that would just have the contactor here, and so that will be coming sometime down the road. But even with this existing solution, we estimate about $800 to $1,000 in components and labor cost going with this solution. So we are planning, I think the plan was sometime in Q1 of next year, to start incorporating our flex power systems, the FP2, 3, and 4, with some brackets so that the, as well as the FPR or FP radian to accommodate the FM100. And we also have some new circuit breakers that are rated at 300 volts because we're going to need to have those, the higher voltage ratings, and as well as the higher current ratings as well. So overall, we feel like the FLEXmax 100 is the cost-effective solution. The 300 volt VOCs that enable two-string arrays are going to reduce the BOS and installation costs. The higher 100 amp output is going to allow for higher power modules, higher powered arrays, and some have the amperage, some have the voltage, but only OutBack has both. So that's where we really feel is going to be the strength of this product. So now I'm going to go ahead and open things up for questions. Okay, so let me get to the top. Okay, a lot of sound checks here, appreciate those. What is the amp hour capacity at 40 Celsius? We are working a project to improve in Amazon. So we do have a D-rate curve in the manual. I'm not sure off the top of my head what that is. The manual is going online. We looked at the curve yesterday, but it wasn't fully updated. So within, I believe, by the end of next week, for sure, we should have the FM100 manual up on the website, and that D-rate curve will be in there. Question is 300 plus volts a failure condition? I believe so. Now, I'm not sure what, like I say, we're rated up to 298 technically. It does go into a standby condition at 290 to help protect with it. But yes, over 300 volts, we do not guarantee that it won't fail. So in other words, the higher you go over that, the more chance there is for failure. So yes, it must be less than 300 volts. Question: FM100 won't work at all with Mate 3 non-S. That's true. Only works with the Mate 3S. Is there any plan to allow the charge controller to be controlled by a third-party BMS? I'm not sure what kind of control that would mean. Battery, I'm assuming you're talking about a battery management system. We do speak Modbus SunSpec. So I'd say if that third-party BMS wants to control anything on the charge controller and it knows how to speak Modbus SunSpec, then yeah, the answer is yes. How is the rapid shutdown returned to normal operation state? You just flip the switch from the off to the back to the on. I know it seems a little backwards, but you just flip it to the opposite direction. So as long as it's in rapid shutdown mode, everything will be in that mode, and so you just turn the switch back to its normal operating position. I think that you have the greater than in the wrong direction on system diagram. Okay, I will take a look at that later. Thank you for that. As I understand what you were saying about the RSI, it can be used to shut the inverter off. Here's my problem: in the event the power is shut off due to fire and the inverter is in the power source for the water pump, you don't want a shutdown to happen. So as I see it, human intervention is required to prevent this. Well, you have the option. You don't have to connect the rapid shutdown device to the inverter on-off. So yes, you always have the option of doing it manually. The only reason we bring that up is we've been told that some AHJs want to see the backup power load panel shut down along with everything else. So that, but yes, so the manual shutdown is always an option, and that's something you'll need to work out with your site owner and the AHJ. What about a string sizer? We do have we have a system sizing tool which also includes string sizing. I don't recall if the string sizing tool we used to have on the website is going to get updated or not, but we do have a system sizing tool which I believe is on the website. And we will probably be doing a webinar on system sizing that will utilize that tool next year. And in the meantime, if you can't, for some reason you can't find it on the website, for sure you can get it through our tech support group. Okay, can you give an idea of list pricing comparatively? The charge controller all by itself, not including any other BOS type components, I'm told is about $1,200. When can I order one? You need to talk to your local distributor. I believe some are I'm not sure who's receiving which ones first, so you just need to check around and check with your local distributor to find out when they'll be available. Will this product be available in Q1? Yes, definitely. The plan was to start shipping before the end of the year, but definitely Q1. What can the FM100 do with an input of 20 volts? That's a good question. I'm not really sure. That's just what the specification is, but you bring up a good point. I'm not sure what kind of power you can produce at 20 volts DC, especially when the battery is rated to 24 volts. Is this PowerPoint available in PDF? Yes, we will make this available. I had planned on having a handout actually with this. I apologize I didn't get to that. I made some last minute changes. So I believe that we will send them out to you. If not, if you don't receive something by the end of this week, check back with tech support and we'll make sure that you get a copy. Or you can contact sales@outbackpower.com, but give us a day or two to get those out to you. Okay, getting down to the end of the questions here. Is there a constant voltage charging mode for lithium? I don't believe there is. You know, that's a very good question, and I need to figure that out actually. I don't. You could try setting the absorbed voltage and the float to be the same, but there's a application note forthcoming that explains some different ways to do these things with the Simplify battery, and I'll discuss this application of how to do the settings on the inverter versus the charge controller. And so yeah, I don't have a quick and simple answer for that. I apologize for that. So yeah, if you're just using charge controllers, I'd want to noodle that one out before I gave an answer on that. But you can send me a message through support@outbackpower.com, and I can follow up with you. Can I swap the FM100 for FM80 on an existing FPR4048A Radian? Well, on the 4048, since there's only a single charge controller, you might be able to do that. You might have to move the Mate 3. I really don't know. We haven't addressed that question yet. So I'll have to give you the answer of I don't know, but since it's only one charge controller and the Mate 3 on that panel to the right of the Radian, I would expect the answer is yes, but I'm not certain. Will the FM100 do a CV mode without batteries? CV mode, constant voltage mode without batteries. It is not designed to work without batteries. Is it a must to use the RSI? It is not a must to use the RSI if you're not under, you know, the NEC code compliance of 2014 and 17. So if you don't need to be NEC compliant, then you don't need to use the rapid shutdown. Can the FM100 be used with additional rays and still keep an FM60 in operation? I don't see why not, but the only problem I could foresee is how you would integrate the rapid shutdown. I think that would be possible, though. With the FM60s, you'd need to use the remote trip breaker and the breaker control module. Yeah, that shouldn't be a problem. Again, I haven't really noodled that one out yet, so I'll give a tentative yes on that one. Can you connect the FM100 with the FM80 and have charge coordination? I don't know, and I will write that question down. Okay, so yeah, I would have to get back to you on that. If you would like a follow-up on that, just please direct that through support@outbackpower.com, and I'll make sure that those guys get our tech support group gets the answer. Comparatively between the FM80 and 100, I'm not sure what's being asked. Maybe you can follow up with another question. Is the FM100 available for purchase now? They'll be shipping soon, and I would talk to your local distributor to find out on the availability. Okay. Can the spec sheet be changed so the lowest useful input voltage be stated as the lower recommended input voltage for battery charging to avoid customer confusion? I will talk this over with our product management group and see what they have to say about that. I can't answer that question right now, but I will certainly put that forward to our product management group. This is off-grid, so the rapid shutdown is not critical. Okay, so yeah, rapid shutdown is not a requirement for the FM100. If rapid shutdown is not going to be used, then you would just put a little jumper wire between terminal 1 and terminal 3 on the input control block. That's the yellow terminals and the purple terminals. So you just put a jumper between the yellow and the purple, and then that way you don't need to worry about rapid shutdown. It won't disable the output. Okay, so that looks like that's all the questions. Thanks again for everybody taking the time to attend the webinar. We will be having a repeat of this webinar at 11 o'clock this Friday. Okay, thanks everybody.